Welcome to the DIY Honda Garage channel. DTC P1129 stands for Map Sensor Signal Higher Than Expected, which specifically pertains to the 2006 to 2011 Honda Civic models. This diagnostic trouble code indicates that the manifold absolute pressure, MAP, sensor is providing a signal that is above the expected range during operation. The MAP sensor is critical because it measures the pressure within the intake manifold, allowing the engine control module, ECM, to adjust the fuel-air mixture for optimal combustion. When this signal is off, the vehicle may experience performance issues like rough idling or decreased fuel efficiency. It's crucial to address this issue promptly, as a malfunctioning MAP sensor could lead to more significant engine problems down the line. Proper diagnostic procedures should be followed to pinpoint the root cause, aiding in achieving a successful repair. The error indicated by DTC P1129 involves several important components within the vehicle's intake management system. The manifold absolute pressure MAP sensor is directly impacted, as it plays a crucial role in measuring the pressure of the air entering the engine. Another aspect to consider is the vacuum system, which includes components such as the positive crankcase ventilation, PCV valve, PCV hose, evap canister purge valve, throttle body, intake manifold, brake booster, and brake booster hose. These components work together to ensure that the engine receives the correct air-fuel mixture under various conditions. Additionally, the engine control module, ECM, or powertrain control module, PCM, must also be checked, given that any shortcomings in the connections or terminals can lead to false readings and poor engine performance. Recognizing these components, locations, and functions is essential for efficient troubleshooting and eventual repair. There are several possible causes associated with DTC P1129 that need to be considered. Firstly, vacuum leaks can cause the MAP sensor to read incorrectly, leading to the high signal error. It's essential to inspect components such as the PCV valve, evap canister purge valve, and hoses associated with the brake booster, as all can contribute to vacuum leaks. Another potential cause could be a faulty MAP sensor itself, which may require replacement if it does not provide accurate pressure readings. Lastly, electrical connection issues between the MAP sensor and the ECM, TCM could also be blamed for the improper signal. Keeping a systematic approach will ensure that no potential cause is overlooked during the troubleshooting process. When DTC P1129 is present, you may notice specific symptoms indicating that corrective action is necessary. One prominent symptom is poor engine performance, which can manifest as sluggish acceleration or a general lack of power when driving. Additionally, rough idling may occur where the engine struggles to maintain a stable RPM, resulting in vibrations felt within the vehicle. Another common indicator is decreased fuel efficiency, which stems from improper air-fuel mixtures due to the erroneous signal from the MAP sensor. These symptoms underscore the need for immediate diagnosis and resolution to prevent further complications and ensure optimal vehicle operation. The first step in diagnosing DTC P1129 involves checking for vacuum leaks throughout various components of the vehicle. It's vital to assess components like the positive crankcase ventilation, PCV valve, PCV hose, evap canister purge valve, throttle body, intake manifold, brake booster, and brake booster hose. These parts can develop leaks due to wear or damage over time, leading to incorrect readings from the MAP sensor. If any leaks are detected, they should be repaired or replaced immediately to prevent further issues. An accurate inspection will determine if the vacuum system is functioning correctly, laying the groundwork for further diagnostic steps. In the second troubleshooting step, begin by starting the engine and holding it at an engine speed of 3,000 revolutions per minute, RPM, without any load. This situation typically means that if your automatic transmission, AT, is in park or neutral, or if you have a manual transmission, MT, it should be in neutral. Continue this until the radiator fan activates. This indicates proper operation of the cooling system. Afterward, allow the engine to idle. This step is essential because it helps to stabilize the readings from the map sensor under controlled conditions, facilitating a more accurate diagnosis based on the following steps. For this step, utilize the Honda Diagnostic System, HDS, to check the map sensor data listed in the diagnostic menu. You will be looking specifically for whether the pressure reading exceeds 36.9 kilopascals, kPa, which converts to approximately 11.0 inches of mercury, or 277 millimeters of mercury, millimeters Hg. If the sensor indicates these values for longer than 5 seconds, you will proceed to the following troubleshooting step. However, if the readings do not meet this criteria, you will move to step 4 to reset the diagnostic trouble code, DTC. Monitoring the sensor data closely allows for targeted identification of potential faults within the system, effectively guiding troubleshooting. In this step, clear the diagnostic trouble code, DTC, using the Honda Diagnostic System, HDS. This action resets the system and clears any error codes that were previously stored in the Engine Control Module, ECM. Clearing the DTC is essential as it prepares the vehicle for subsequent test drives and checks. Once the code is cleared, you can proceed to test the vehicle under specific conditions to evaluate its performance. This step ensures that you will have a clean slate to work with, allowing you to better assess whether the issue has been resolved or if further investigation is required. Step 5 involves conducting a test drive under stipulated conditions to evaluate the engine operation more accurately. Ensure that the engine coolant temperature, ECT Sensor 1, indicates a temperature above 158 degrees Fahrenheit, 70 degrees Celsius. Within this drive, you should maintain the engine speed between 1,200 and 5,400 RPM and have the automatic transmission in drive, or the manual transmission in 5th gear. The vehicle should travel at a speed of 55 to 75 miles per hour, 88 to 121 kilometers per hour, for a solid 10 seconds. During this test, fully close the throttle and decelerate for a minimum of 5 seconds. This procedure allows for a realistic assessment of the engine's response and performance under typical driving conditions. After completing the test drive, the next step is to monitor the onboard diagnostics, OBD status, for DTC P1129 using the Honda Diagnostic System, HDS. If the system indicates failed, it directs you to the following troubleshooting steps, possibly involving the map sensor itself or other underlying issues. If the system indicates passed, it signifies that the vehicle has temporarily sauntered through the diagnostic process without faults. At least at that moment, the intermittent failure status signifies that no faults were present during testing, but could still recur, warranting an examination of connections or terminals at the map sensor and the ECM/PCM. Understanding the outcome of this monitoring is crucial for determining the necessary follow-up actions. In the 7th step, turn the ignition switch to the lock position, or 0, to ensure that the electrical systems are off while you prepare for further work on the vehicle. This is an important safety measure that prevents unintentional startup or electrical engagement during the next steps. At this point, if it has been determined that the MAP sensor is faulty based on the previous checks, it is time to replace it. This process requires careful handling to ensure that the new map sensor is correctly installed, preventing any issues that could arise from improper fitting or connection. The 8th step involves replacing the faulty map sensor identified in the earlier diagnostics. Proper removal of the old sensor is crucial to avoid damaging the mounting and surrounding components. When installing the new map sensor, ensure that it is seated correctly and that all connector terminals are clean and secure. A proper fit is essential as it affects both performance and the longevity of the component itself. After replacing the map sensor, it is advisable to perform a quick check to confirm that there are no residual codes due to installation errors. Taking this care in replacement can help to ensure a successful resolution of the signal issue. Next, turn the ignition switch to the on position, or II, to prepare the vehicle's electrical systems for the next series of actions, primarily focusing on the ECM/PCM. This step ensures that the vehicle is ready for diagnostics and resetting procedures. Keeping an eye on the various warning lights during this initiation phase can also provide preliminary insights into any other existing issues. It is essential that you do not engage the engine at this stage. Rather, allow the systems to bootstrap properly before proceeding to the next step. This preparation phase is pivotal in establishing a clean, functional state for the next evaluation. In this step, utilize the Honda Diagnostic System, HDS, to reset the Engine Control Module, ECM, or Powertrain Control Module, PCM. Performing this reset is essential for returning the vehicle's electronic systems to a baseline state post-repair. A reset eliminates past error codes and allows the newly installed map sensor to function accurately from its initial startup. It is imperative to ensure that the ignition remains in the on position throughout this process, which enhances the reliability of the reset. This step creates an environment where fresh diagnostic data can be collected during subsequent operations, benefiting the overall repair workflow. Once the reset of the ECM/PCM is completed, execute the idle learn procedure for the engine control module. This process involves allowing the engine to stabilize at idle, enabling it to adjust to the new parameters set by the newly installed MAP sensor. Performing the idle learn procedure helps the ECM/PCM recalibrate and learn the correct idle conditions. This step is pivotal because it ensures that the engine operates smoothly and predictably, aligning closely with the manufacturer's specifications. A successful idle learn procedure contributes to optimal fuel efficiency, performance, and overall vehicle reliability. In this 12th step, repeat the process of starting the engine and holding it at an engine speed of 3,000 RPM without load until the radiator fan comes on, just as done initially. This action assists in stabilizing the map sensor readings under similar controlled conditions as earlier described. After the radiator fan activates, allow the engine to idle and monitor the performance indicators. This step acts as a final verification of the repairs made and the successful integration of improvements in terms of intake pressure readings. The results obtained from this step will provide conclusive evidence on whether the initial issue of the map sensor signal has been resolved. The final repair verification involves a thorough review of the diagnostic codes once again. Specifically, check to ensure that DTC P1129 does not reappear after completing all the previous troubleshooting steps. By utilizing the Honda Diagnostic System, HDS, you can confirm that the system shows no current or pending P1129 codes. Additionally, it's beneficial to monitor the vehicle's overall performance, such as acceleration, responsiveness, and engine idling characteristics. Successful verification indicates that the issues associated with the map sensor have been satisfactorily addressed, leading to stable engine operation. thus validating the repair work conducted. Preventive maintenance is an essential aspect of vehicle care, particularly concerning issues indicated by DTC P1129. Regular checks on vacuum components can help identify problems like cracks or leaks before they escalate into more significant issues. Components such as the PCV valve, hoses associated with the brake booster, and associated sensors should be inspected every few months, ensuring that they function properly. Additionally, routine inspections of the MAP sensor can prevent future failures by ensuring that it remains clean and in optimal condition. Taking the time to perform these preventive measures can prolong the lifespan of the MAP sensor and enhance overall engine performance. In conclusion, addressing DTC P1129 requires a systematic approach, starting with the identification and repair of any vacuum leaks that may affect the MAP sensor readings. Confirming the integrity of the MAP sensor and connections to the ECM/PCM is critical for the vehicle's performance and efficient functioning. If necessary, replacing the MAP sensor is a direct solution to rectifying high signal issues. Furthermore, regular maintenance and checks can ensure the longevity of these components and avoid the recurrence of similar diagnostic trouble codes in the future. By adhering to these guidelines, you can foster optimal performance within your 2006 to 2011 Honda Civic, ensuring a reliable and enjoyable driving experience. Please like and subscribe to the channel. See you next time.